Now we'll look at the set of samples where gold has been deposited on nickel and nickel on top of that. We'll use the optimized background facility here to make an automated determination of the best fit to the background. So to use that, we first click the spectrum and we're looking for the best fit to the background. And instead of doing this manually, I'll just hit here on simplex. We use the simplex algorithm and it will now operate between these two lines. So the energy range from here to here, it will be looking for the best fit of the background to that by varying these two, the start depth and the end depth. So hit background and it will search for that and quickly find the best fit. So it's about the same as we had before. We can take the next one where we have gold deposited on top, hit background, and we quickly get the best fit here from around 10 to 20 angstroms. You can have a look at this and look at the RMS value also. When you vary the start depth, it clearly gets larger. And we can change the increment here to 1. And you can use this. You see we really have a minimum. But you can use this to get an idea of or to determine the uncertainty on these numbers. In this case, it's about 1 angstrom. You see the RMS value varies here as you do this. For the first sample, we have that here, hit the background, and it quickly finds the best fit is from around 25 to 35 angstroms. So this is how you use the optimization facility here. There's a small manual. If you click info here, so you click info here, you'll get a short description of what happens. Same here if we go to simplex, again click, there's an info, same place. Here, info, you get a short description and the user's manual, which also describes the set parameters here. Set parameters sets up the values that the search will use as starting values for the changes in the start depth and end depth as it looks or as it steers towards the minimum in the RMS value. The F tolerance here is a number which determines when to stop. So when the change in the RMS value as you go from one set of parameters to another set is less. If the improvement is less than this value, it will stop. Maximum number of iterations is given here, so it will stop if it reaches 200 in this case before this is met. The max depth here is the maximum depth that it searches. This is given in units of IMFP. So in this case, it will be the product of 13.6 and 25, which is about 300 angstroms. So it will not be searching for depths or variations when these depths are larger than about 300 angstroms. And the reason for that, of course, is that we don't have much sensitivity in the spectrum when we have very large depths. But this can vary depending on the situation. So you normally not need to use these. You just use these default values. There's another possibility, and this is the Powell algorithm. The Powell algorithm uses a different way of steering towards the minimum. And also here you have an info here, and you can set parameters. This is now a vector here, which describes the initial vector that it will be using to search for the minimum in these dx1, dx2. And again, we have a tolerance, maximum iteration, and max depth. The two algorithms differ in the way they steer towards the minimum. I've found, a lot of examples, I've found that simplex is practically always faster than the Powell algorithm, but they give about the same answer. So normally you would just be using the simplex algorithm.